All right, so we're starting with a little bit of general practice and review kind of stuff here. And so for number one, it's a rounding practice, rounding review. And so in this case, we're rounding to the second decimal. So I count over to where the second decimal is, and I see that's where that 9 is. Remember that as I go from here, the only number I care about in terms of what's going to happen to that 9 is the one next digit. So this whole 803 out here, it won't have any effect whatsoever. It never would. But that one next digit, which in this case is also a 9, this one right here, that one does have an impact. That tells us that either I'm going to leave this a 9 or I'm going to round it up. So does it stay or does it round up? It rounds up, yeah. Because if that next number is 5 or more, it rounds up. Basically what we're doing here is we're faced with a decision. We are asked, is our answer here going to be closer to 534.19 or is it closer to 534.20? Because I'm just taking that 19 and going up by the smallest amount I can. And so, since it rounds it up, it tells me then that it's the bigger of the two. So then this is our final answer, 534.20. Now, little detail here. Do you have to write in the 0? Technically, you don't have to write in the 0. If you wrote 534.2, that equals the same thing. However, by writing in the 0, you are saying that this is accurate out to 2 decimal places, which is what we were supposed to do as part of this rounding, is we were supposed to write out what it would be accurate to that. When we leave that off and just write 2, all we know when we look at that number is that it's accurate out to 1 decimal place. So in rounding, yes, it's a good idea to put that 0 in, even though it doesn't change the value of the number itself. All right, so then on the next one, we do the same kind of thing, where we're rounding to 3 decimal places, so I look to see what number is in the 3rd decimal place. It's another 9. You notice a pattern here. These are the types that tend to trip us up sometimes, and so I'm giving a decent number of practice problems on them, so we can see how this gets dealt with. All right. I need to look only at the one next digit. So this 458, that stuff isn't going to matter. And so in this case, I look at that one next digit, the 7, and is that going to change my number? Yes, that tells me to round it up instead of leave it alone. Okay, so then, what is my choice then? What am I choosing between? Well, the lower number option would have been 3.899. But I actually need that to be a little bit higher. Well, if I round up this 9, it's like making it into a 10, but we carry the 1 to the next one. But notice that's already a 9. So what's closer then on our way up is actually 3.899. If I go up 1, I go to 900. It's basically like carrying a 1 up. Or you just say, hey, what's 1 more than 899? 900. And since we were supposed to round up, that means that's our answer. It's going to be 3.900. And yes, again, I'm including the zeros just to point out that it's accurate out to 3 decimal places. Oops. This would be equivalent. 3.9 would be equivalent to it. It's the exact same value, but that's only accurate out to 1 decimal place. This is showing that it's accurate out to 3 decimal places. So little detail, but useful. So this next one now is simplifying. Notice this kind of looks like the work that we did yesterday, right? In fact, it's just a very simplified form of what we did yesterday, and just one that you tended to already see come up quite a bit in other applications. We're still going to just take whatever is out front and distribute it into everything inside. So if I do 2 times x, well, that's just 2x. The minus stays a minus. 2 times 5 gives me 10. There you go. That's it. That's the final answer. 2x minus 10. And then we hit this last one where we're solving. A little detail here. You notice the number 3, I said simplify, not solve. Sometimes we get those terms mixed up. Solving means I'm going to be able to end up with an answer that's like x equals something. If it's going to be x equals something, that means that we have to have an equation that has an equal in it. I can't solve number 3 because there's no equal sign. That question comes up now and then. It's worth mentioning. All right, so if I'm going to solve number 4, I got a few different options about what I might do at the start, but remember, solving ends up giving me a final answer that has x by itself. Right now I have multiple x's, so I'm going to try to actually move those x's to the same side. A great way to start this one is actually subtract x from both sides. And the cool thing about this particular problem and the way it was set up is that when we do that, on the left side we just have a 3 left, and on the right side 2x minus x. Notice I can subtract them. They are like terms because the exponents are the same. They're both x's. It's not like x and x cubed or something like that. They're both just plain old x. And so 2x minus 1x, and that's what x is, 1x, gives me just 1x, which is x. So in other words, 2x's minus 1x gives me an x. And since it's just x equals now, that was our goal, we're done. We solved it. I want us to take a look at this graph and write the equation for it. So bringing back some of our graphing principles. So as you take a look at this graph, in order to write the equation, there's kind of a few mental steps that we have to go through. The first thing is starting by deciding what type of equation it is. What's the parent function, in other words? Well, what gives us the V shape? Absolute value. So I know then that I'm going to be dealing with something that starts as absolute value of x. But of course, absolute value of x, if that's all it were, it would actually be a V sitting over here at 0, 0. This one's been shifted. All right, so it's specifically been shifted right 5 and up 1. So it's just a matter then of how do we write an equation for absolute value of x that's been shifted right 5 and up 1. All right, so start with the y equals, and then we start the absolute value. Now, do we need to use y or could we write f of x? They are interchangeable. You could write this as y equals or you can write it as f of x equals. Yes, either way. So I chose to write as y equals. The absolute value of x, now I need to move it in the x direction, right? I need to move it right 5. So that tells me the 5 is inside the absolute value. The only question is, if I'm going to go right, is that plus or is that minus? It is minus, yes. All right, one last piece to our equation. The movement up and down. I'm moving this graph up 1. Well, whatever we move it up or down, that's going to be the number hanging on the end here. In order to move it up, is that plus or minus?
Plus.
It is plus. And so then that is your equation. Y equals the absolute value of x minus 5 and the absolute value plus 1. All right, so then, how do we write the equation for this graph? We first start again with what type of equation is it? The name is quadratic. Yep. Which means that as an equation, it starts out as y equals x squared. Or again, f of x equals x squared, perfectly fine. All right, so I know I have an x squared graph. Now I look to see which ways it's been moved. Now when deciding where it's been moved to, I'm looking to see where the point is that's normally over here. And normally our u does one of these. It bottoms out there, so this is the critical point. That's what I'm looking for. So based on that point, I know that this graph has been moved to the left 4 units, and it has been moved down 2 units. And so that's the equation I'm writing. In fact, I could just tell you this part over here, and you could write the equation just from that, right? So I'm going to write an equation for y equals x squared that's been moved over. Now, when I move it over, that means I need to be able to put that 4 inside with the x. I need to have the x in the 4. But the squared is no longer sitting here on the x. I have to do the 4, either added or subtracted to it, before I do the squaring. And so that's why we introduce parentheses here. So that I can say that I'm going to do the plus or minus 4, and then it's squared. But the squared still has to be there because, of course, that was part of our parent function. Now, in order to go left, is that plus or is it minus? To the left is plus. Yes, very nice. And it's true for every type of equation. Plus will always move it left. All right, and then in order to go down 2, I put the 2 at the end. Down, is that plus or minus?
Minus.
It is minus. And again, every single type of equation, minus moves it down 2. And so then that's our final answer. That is the equation for this graph.